Welcome to lecture 7 in a microcontroller series. So in the last lecture we discussed about the instruction sets of data transfer instruction and arithmetic instructions. So this lecture we are going to cover the logical instructions and branching instructions. So as I told, the logical instructions is used to perform, or mnemonics used to perform and logical operations like basic logical operations like AND, OR and XOR operations. So we are splitting the logical instructions into two types, that is a byte level logical instructions and bit level logical instructions. In byte level logical instructions we are manipulating for bytes, and bit level instructions we are manipulating the bit level data. In byte level logical instructions AND, OR, XOR and NOT operation we are going to do, and in bit level manipulations, so these bit level manipulations are also called as Boolean operators. Boolean operators we are mentioned in instruction types of instruction set as a fifth type, but here in this lecture I included that Boolean operators in logical instruction itself, because these are performing in bit level Boolean manipulations, that is RL, RLC, RR, RRC. So these are bit level logical operators. Byte level logical operators, let us see the byte level logical operators. That is basic operation of logic gates, that is AND, OR and XOR. So AND operation can be performed in 8051 by using ANL instructions, ANL of destination operand and source operand, that is performing an AND operation between source and destination and store the result in destination operand. Here ANL A, as data. This is related to all four types of addressing mode. 8-bit of data and accumulator content OR operation need to perform. Result will be stored in accumulator content itself. Similarly, with memory location and accumulator, OR operation performing and result will be stored in accumulator. And here the register content and accumulator content will get ORed and result will be stored in accumulator. Here the resultant of that is memory location content pointed by a register will be ORed with the content of accumulator and result will be stored in accumulator itself. So next, OR operation we are going to do using 8051 instruction, that is ORL destination and source operand. That means OR operation performed between destination and source, result will be stored into a destination itself. ORL A, as data, that means data of 8-bit data is ORed with accumulator content, result itself stored to accumulator. Similarly, memory location to accumulator OR operation, result will stored in accumulator itself. And XOR operation is also same. XORL instruction is used to perform XOR operation. So destination and source operand will get XORed, result will be stored into a destination operand. XORL A, as data, 8-bit of data and content of accumulator get XORed and result will be stored in accumulator itself. Bit level logical operators. So this is about byte level logical operators. So bit level logical operation. So this bit level logical operators is used to manipulate the special function register bits, because special function registers are 8-bit combination registers. Those bits can be manipulated by using these instructions through the software file. So bit level logical operators, they are CLRB, CLRC and set bit, set BC and complement of B. CLR bit, that means we need to reset any bit in special function register, that is IE, IP or any register or ports. You can mention that port number or bit in this position, so that bit will get cleared. If you are using CLR port 0.0, the port 0.0 will get cleared or it will become reset. So software way of clearing the bit can be performed by using CLRB, and CLRC is used to clear the carry flag. Similarly, setB is converse of this CLR bit. We are setting the particular bits, that is set P 0.0, that indicates the port will get enabled. Port 0.0 will get enabled. Similarly, we need to set the carry flag by using the bit, by using the instruction set BC, and CPL is used to complement the bits. That means if bit is 0, if you are using this instruction, after this execution of this instruction, the bit will get complement of what exactly content is there in the bit. And some ANL of C comma B, that means AND operation between the bits of AND operation between the set bit and carry flag. So this is also bit manipulation instruction. And ORL of carry with the bit operation, set bit, it will be stored into the carry, so that is also bit manipulation operation. And move C comma B, that is content of B bit will be transferred to the copy to the carry flag, so these are also bit manipulation operation. So important bit manipulation operation, that is RLA and RLC, RRA and RRC are the very significant rule, and that is significant instruction set which is used in data manipulation during data conversions. RLA is rotate accumulator left. So by using this instruction, the accumulator content bits will be shifted towards the left. Bit after bit it will shifted towards the left. That means here the 8-bit pattern of accumulator content, D0 will shift to D1 and D1 will shift to D2, D3 will be shift to D2 will shift to D3, D3 to D4. At the last content D7 will again go to the round robin structure, that is D0. So D7, if you are execute one time instruction, so D0 will shift to D1 and this D7 will shift it to D0 position. Therefore A of n plus 1, that is an will be transferred to an plus 1, or dn will be transferred to dn plus 1, and this d7 will be transferred to d0. Similarly, RLCA, same rotating operation, rotating accumulator left using the carry flag. Here one carry flag we are going to use. By affecting this carry flag, we are transferring the we are shifting the information towards left. Here the data d0 bit will be copied by, once we are applying the RLCA, the content of, that is content of d7 will be copied to the carry flag, and the carry flag content will be copied to the d0 position. Similar operation for RRA, rotate accumulator right, that is the content of accumulator will be shifted towards the right side. That means d0, that is d7 will goes to d6 position, and d6 to d5, 5 to 4, 4 to 3, 3 to 1, 1 to 0. d0 will transfer to d7th position. That is the major operation in RRA. And in RRCA, the one more carry flag we are using here to transfer the data. The carry flag, that means the d7th bit will transfer to d6, 6 to 5, 5 to 4, 3 to 2, 2 to 1, 1 to 0. This d7 will transfer to the carry bit, and carry bit will be transferred to the d7th position. So this will be found in RRCA. And one more last bit level logical operator, that is swap. Swap operation or swap instruction is used to transfer or exchange the higher nibble with the lower nibbles. That is higher order 4 bit will be comes to the position of lower order byte, and lower order byte 4 bits will be transferred to the higher order byte. That means A0 to A7, A0 to A3 will be transferred to A4 to A7. So this is about the logical instructions and Boolean operator instruction sets in 8051. So one more last instruction set as we are going to discuss, that is a branching instruction set. So branching instruction set, so these are the instruction set which changes the control flow, that is CPU control flow of the main program included with the action codes, which also changes the content of the program counter. That means it will transfer the execution control of the main program to the any other part of the program or the subroutine, or else inside the main program. If we are changing the execution control inside the main program, we can use the jump instruction. If you want to change the execution control from main program to another part of the program, we can use the call instruction. Therefore only the two instructions, branching instruction, we are using, that is jump and call instruction. So before that we need to know the range of the instruction. So range is nothing but the instruction address difference in byte between the current location to the new location is defined. For example, here is one diagram. Inside this, some instruction, the main program is executing at the position of 806. If the jump will occur in this condition, it will go to 8016th location. So therefore the program counter is loaded with this location, and it will start to execute from this position. So it is jumps from 8006 to 8016. So therefore range will be A10, that is 10H, that is byte, 10H byte of instruction, that is my location it is transferred, therefore it is called as range. So based on that range, we are classified it into a relative range, absolute range, and long range. Relative range is nothing but jump happens between relative address minus 127 decremented by minus 127 to plus 127 address locations of the program counter. And absolute range, jumps takes place in between 2 KB of RAM. Long range is nothing but jumps takes place within 64 KB of RAM. That is called the ranges of branching instructions. And so let us come to conditional, that is jump instruction. First we'll start discussing about the jump instructions. So jump instruction, that is two types of jump instruction you can see in 8051, that is conditional jump and unconditional jump. So conditional jump is nothing but if the jump will occur if the condition will get true, or if the condition is true then jump will occur, otherwise it will go to the next instruction. So here also we are splitting the jump instruction into a bit level jump instruction and byte level jump instruction. In bit level jump instruction, that is jump if carry, that means if the carry flag is set, the jump will occur, otherwise it will go to the next address. Therefore program counter is incremented. If carry is set, then the program counter is added with the relative address which is mentioned in this position, and it will loaded with the program counter value. Similarly, contrary to the JNC, if the carry flag is not set, the jump will occur and it will go to the relative address, otherwise it will execute the next instruction. Similarly for JB, that is jump if bit is set to the relative address, that is if bit is set, the jump will occur to the relative address, otherwise it will go to the next operation. And here is and the jump if no bit, converts to the JB, if bit is not set, then jump will go to the relative address, otherwise it will go to the next operation. And if jump bit, a clear bit instruction to the relative address, that is if the bit will set, once the bit will set, or once it will get cleared, then it will jump will occur, otherwise it will execute the next instruction. That means once the bit will set, and once it will set, it will get cleared. So once it will clear, then only the jump will occur. That type of instruction is called JBC. And byte level jump instructions, those are CJNE, JZ, JNZ, and DJNZ. So these three are major 4 byte level jump instructions we are repeatedly using in 8051s. That is CJNE, that is